Hello and welcome to some simple file processing in C. This will be our last lecture before our final exam, so let's go ahead and get started. Today we will be covering sections 11.1 through 11.4 in our book. We're going to talk about files and streams and what they are and what differences are and some similarities, and then we're going to end up with sequential file access. Your book does go into random file access, but we are not going to cover that in lecture today. So our objective for today is to understand the concepts of files and streams and to learn to use sequential access text files, write and read. So when we have data in variables, it is considered temporary, and we lose that data when the program terminates. It's just disappears, it's gone. But a file will enable your program to have long-term data retention and to be able to reuse it in the future. We're going to talk about how to create, update, and process data files. And again, like I said, we are going to talk about only the sequential access and not the random access. So files and streams. C views each file as a sequential stream of bytes. So just as if it were any other form of data, it is going to see it as a stream. Each file is going to end with some type of end of file marker, or at a specific byte number in which we know the number. So say I have information only through 0 through 10, I will know to stop at 10. We need to have that number though in some sort of data structure or in something within the file within the very beginning of that file. This is completely platform dependent and it's hidden from the user and the programmer. Some standard streams though that we do have in every program is that a standard input is the keyboard, which we've used before, and our standard output is going to be the screen. And we have a standard error output, which actually does display to the screen as well. We can alter these to have input and output from other resources other than the keyboard and the screen. We have a file structure, and what we do when we open a file structure is that we are now going to have a pointer that is going to indicate where in that stream that we are. This is all defined in the stdio.h, which is what we've used in the past, so there's nothing new there for libraries. We may include a file descriptor or an index into some kind of array called an open file table. Each element contains a file control block or an FCB, and the information the operating system uses to work with a specific file is going to be in that FCB. We can manipulate the standard input and standard output and the error stream as well using the file pointers stdin, stdout, and stderror. So if, for example, we want to keep the standard input as a keyboard and the standard output as a screen, we can create, say, an error log and divert the standard error streams into a hard file. So for file processing, we have a function called fgetC. So F for file and then getC. So it's very similar to getChar, and it's going to read one character from the file specified from the file pointer. So that file pointer is going to point to a specific character and it's going to read it in. We also have fputC, so F for file, and put, and it's just like putchar. And it's going to write the character in the first argument to the file where that file pointer is pointing. Some other thing that we can do is fgetS, fputS. That will be a line or a string, as we have learned before. So fgetS is going to read a line of text in from the file, and fputS is going to write it or put it into the file. So we're going to look a little bit closer at the fscanf and fprintf, which are going to be the equivalent of scanf and printf. C itself does not have any file structure that it wants to use. Okay, so there's nothing, you can put any kind of file structure. So ideas such as a record of a file or file information, we don't have that in the C language. But what we do is we just use it as a bunch of text or a bunch of data. So we have a pointer to a file, and your program is going to refer to each open file with a separate file pointer. So file is going to be your pointer type. You're going to give it a variable, and so you can actually open and close and write and read from multiple files at one time. You don't need to know the file structure's specifics in order to use the file. This is that whole idea of hiding the details from your user and that notion of abstraction. In order to use a file, we have to open the file. And just like we do with our variables and our functions, there's going to be a couple things we do with a file. We're going to open it, we're going to use it, we're going to close it. So fopen is going to open the file, and it establishes that connection with it. And your pointer is going to point to that file, and you're going to have an idea of basically a direct connection to what's in there. You're going to send it two arguments, the file name and the file mode, the open mode. The file name, you can either have it be relative or an exact file name, so you can include a path information in it if you would like, or you can do it relative to where the program that is running is located. The file open mode W indicates that it's going to be open for writing. If the file does not exist, it's going to create it. And if you open an existing file, it's going to completely delete the file that you have. So make sure that that is what you want before you use fopen. If a file pointer fopen returns a null value, it means that your file could not be opened and there is some type of error. We can also use FEOF to check for end of file. So file, end of file, FEOF. The key combinations of an end of file, if you're using like a notepad, are different on your platform. So Windows, Control-Z, press enter. If you're on a Mac or OS or Linux, it's a Control-D. FEOF is going to determine whether the end of file indicator is set, and it basically indicates to the program that there is no more data to process in that file. The argument is the file pointer to the file to test. It returns a true or non-zero if the end of file indicator has been set. Otherwise, it returns 0 or false. Equivalent to printf, we have an fprintf, and that is a file printf. And that's going to receive the file pointer argument to which the data is going to be written. So fprint is putting an output into that file. Then we can also need to close it. After we're done either reading or writing the file data, we must close it. So first you must open it regardless of what you're going to do. Then you can either read or write. And then finally you have to close those files. We use fclose, and it receives the file pointer as an argument. If you do not call fclose explicitly, normally your operating system will close the file when your program is terminated, but it can leave an open security risk. It is good programming practice to close each file as soon as you no longer need it, and then you don't have the option of forgetting to close it at the end. So some file open modes. We said we have to send it the mode. We said originally we're going to send it W for write. Well, we have a bunch of different modes. R is for read, W is for write. A is to append. So this is going to create a file for writing at the end of a file. So it's going to add things at the end of a file. R plus is for updating, so reading and writing. W plus is for reading and writing. And A plus is for appending and reading, writing at the same time. Now we have a few other ones. We have RB, which is going to open a binary, which is what that B is for. So all of these have that B indicator, so they're all going to be binary files. WB, AB, so write binary, append binary. RB plus, WB plus, AB plus. So it's doing the same thing, reading and writing, updating, and then also binary, creating and updating binaries when you're appending to the end. Some common errors that we have is opening a non-existent file for reading. Your file must exist if you're going to read from it. Opening a file for reading or writing without having been granted the appropriate access rights. This is operating system dependent, but if you don't have the ability to access that file at all, your program's not going to be able to access that file. Opening a file for writing when no space is available. So if you run out of room, it's going to give you an error. Opening a file in write mode with a W when it should actually be opened in the update R+. Remember, W is going to discard anything that's in your file content, so it's going to just completely wipe it out. So if you need to append or write, you do the R+ and not the W. Now, data is stored in files so that it can be retrieved for processing when needed. Remember, this is more long-term storage. Your variables disappear right after the program is finished, but files can keep it for a little bit longer. If a file's contents should not be modified, then open the file only for reading. It's going to keep you from accidentally writing over that information. Again, it could be intentional, could be not intentional. Open a file for reading with that R mode that we just saw in the table. That's read only. Function fscanf is equivalent to your scanf, but it's going to receive the argument as a pointer to which the file you're going to read out of. We said that a file is nothing but a stream, and your pointer is actually going to march through that stream and go through the file either line by line or character by character. So you're going to read at the beginning and then just read through the file to the end. But in some cases, a program may have to process a file several times from the beginning, or you may have to return to the beginning. We have a command called rewind, CF pointer. CF pointer is going to be our file pointer. That's going to reposition that file pointer back out to the beginning at byte 0 of the file pointed to. The file position pointer, it's not really a pointer in what we've talked before. It's an indicator of the byte number of where we are, either the location where we are or where maybe we need to go next. And we call this as a file offset. So that is some great information about sequential file accesses and some information about file versus streams. Let's take a look at what we have due for this week. So for this week, we have homework 9 for File IO and Lab 10. And at the end of the week, we do have our final exam.